Good morning, everyone. There's something about coming last after such adept speakers. I don't know if I should continue presenting or everything has already been said. Yeah, so I'm Onyango Sangoro. I'm a research scientist with the new MAP unit in Dar es Salaam in Ifakara Health Institute. So today I'm going to talk about spatial mapping of malaria risk using school malaria parasitemia survey. This would be spatial temporal analysis. So I think, as has been mentioned before, there has been a decline in malaria prevalence globally, and this is also evident in Tanzania. So here, this is just a box plot of the data that you're going to use for just statistical modeling. So it was collected from 2015 to 2021, and we can see a steady decline in malaria prevalence from 19% to 10% in 2021. Yeah, so as malaria declines globally, then I think the spatial nature or heterogeneity of malaria becomes more evident. So in this slide, I'm just trying to show the heterogeneity of malaria. So on the top map is so this is a map of two primary schools that are neighboring each other in the same district. And so in the top map, we can see one school is reporting a prevalence of about 10%, and the bottom school, which is just next to it, is reporting a prevalence of about 67%. And when this data is aggregated at the district level, the schools there in Tarime district, we see that prevalence of 67% is reported. So here I'm just trying to show how aggregating data at a higher spatial scale, then you are likely to lose some information on the heterogeneity of malaria prevalence in an area. So next, I think for mapping malaria risk, we know that it is essential that we have an ideal data set. So the ideal situation would be you have data that is present everywhere and at all times. But we know that this is not the case. We seldom live in an ideal world. So the data that has been used is usually for mapping malaria surveillance has been usually routine health facility malaria survey data and population-based surveys. And we know that these come with attendant challenges. For example, we've had it being said before that population-based surveys such as MIS and DHS have limited spatial granularity and temporal spatial granularity as well, and they're cost and labor intensive. Health facility data usually just reports the burden of disease in the health system and is not in the population. So our justification for coming up with this project is we're trying to explore the data sets that can be used for malaria mapping. So we thought school malaria parasitemia surveys represent a good data set where this can be done. So basically, the school malaria data set has not been used before to estimate malaria prevalence, and we also think it's cheaper and faster to do compared to the population-based surveys. The children are already aggregated at the school. The primary school, so it's easier to collect. We think it's especially granular because it's collected at the ward level, and also the reports of malaria shift of malaria burden from the under 5s to the older age group. So we think that exploring this data would present a potential data that can be used to estimating malaria prevalence. Basically, just because it hasn't been used before for this, and it might as well present better estimates for malaria prevalence compared to the other data. I'm not saying that it does, I'm just saying potentially. So, yeah. Of course, it doesn't come with, it's not a perfect data set. Of course, it's incomplete. It has its shortcoming, for example, incompleteness. So, for example, if you went to survey malaria prevalence in schools when a child was sick with malaria, then you are likely to miss this data point, and as a result, you would underestimate the malaria risk. It's also a cross-sectional survey, so it misses the temporal variation of malaria or seasonality of malaria. Nonetheless, we thought it was a good data set to explore. So we used data that has been collected from Tanzania from 2014 to 2021. This is just a design of how the data was collected. So it was a cross-sectional survey where all the regions in Tanzania was selected, and then all the councils, so the districts of the councils were selected, and the councils were stratified by different strata, so as epidemiological, malaria prevalence, population, geographics, altitude, all the factors that affect malaria. They were stratified in that way. And then from the strata of the councils, the wards were randomly picked from each of these strata. And then downwards, the schools were randomly picked from the selected wards. And then, of course, the school-going children were randomly selected for malaria and parastemia. So, of course, as a beginning, the main objective of this study was to, as I've said, use this data to be able to map malaria risk. And we use geostatistical analysis to be able to do this. We know about the spatial temporal correlation of areas that are close to each other. So this is why we thought spatial temporal analysis of the data would give us better estimates of areas where we don't have data. So this is just a map of our survey points from 2015 to 2021. So we started, of course, by doing that, and then, of course, we also used a selected we chose covariates from the MAPS database. So this suite of covariates was selected on the basis of how they're correlated to malaria, but then we couldn't select all the covariates. So we used VIF, so variance inflation factor, to select the covariates that had the least correlation. So if we set our standard at a VIF of less than 10, so we selected covariates that had a variance inflation factor of less than 10, and we thought this would have less implications on developing our model. After that, of course, we chose a spatial temporal model. So we modeled the malaria prevalence at ward level using a Bayesian framework, where we had the observed data and the covariates. So we linked the observed data and the covariates using a logit regression model to be able to predict malaria prevalence or estimate malaria prevalence means in areas where we didn't have data. So I think Professor Aheto has already demonstrated this. This is just a spatial temporal model where we have, of course, the beta, the intercept, the x, the matrix. The beta is the regression parameters, and then we have the temporal, random, and spatial effects. And so one thing about this model is we assume that the malaria prevalence, the number of positive children, and the total number of children that were surveyed followed the binomial regression. I think that is all I'm going to say about that, not especially a mathematician. So yeah, so these are preliminary results. Please note it's preliminary results. We're just showing a predicted map at ward level. I think that's the only difference. We're showing prevalence at ward level, and we can see it's similar to what we have in the observed data, where we have high malaria prevalence on the southwest and in the northwest and southeast of Tanzania, and of course the central transect, which always has low prevalence of malaria. So I think it well represents what we've observed in Tanzania from this study and this model, and from previous studies of what has been reported. So here I'm just trying to show, as I'm learning how you present spatial data. So I'm just trying to show the predicted malaria prevalence and what the observed prevalence. So on the left, we have the predicted malaria prevalence in all the wards. And then on the right, we have the wards where malaria data was collected. So as you can see, we were able to predict malaria prevalence in all these areas where data was not collected. I think that is one of the key findings from this study. And then, for example, as Professor said, this is especially important because the NMCP or the policymakers can quickly look at the data and then realize where there's a problem. So we see the ward name Gumbaro in is it Sogea district has a prevalence of 1. Of course, I don't think this is the case. I think this is just a problem with our model, which we are going to look into. But then potentially, so if the model is correct, they would easily go to Gumbaro ward and to assess what actually the problem is, and then be able to come up with targeted intervention measures to tackle such hotspots. So I think that's one of the key findings of this study, or the potential of this study. So we also did a model validation. I don't know if anyone talked about this, but caveat, this was an in-sample model validation, and we know this comes with challenges. So I believe that's why we see such a high correlation, because it's just the predicted versus observed data. I'm sure if we did something like out-of-sample modeling, the correlation we're not sure that our model is that good. So yeah, so this is just one of the steps we're following to try and refine our model, so come up with better model validation methods. I'm at the conclusion. So the conclusion is, of course, the data shows malaria heterogeneity at regional and sub-regional levels. And of course, there's potential for use of this data to be able to identify different prevalence stratas in Tanzania, which can be used for micro-planning. I think the limitations, as I've mentioned, school absenteeism. So you'd miss children with malaria. Children with malaria missing school would be missed, and therefore it would not. The estimation rates would probably underestimate the prevalence of malaria. It's a cross-sectional survey, so you miss the temporal variability of malaria. And we did not integrate the intervention data, so the nets that were used, and we do understand that this is a limitation. So these are some of the tasks that we're going to undertake in the near future. So I think what we are looking to do at the end of this is to see whether we can, so for example, whether the SMPS data, if it correctly estimates malaria prevalence at the ward level, whether this can be integrated with other malaria surveillance data like MIS and health facility data to produce more composite maps. I think that is one of the major outcomes of what we're looking to do in this study, of course, and then explore how representative school malaria data is at representing population malaria estimates, of course, and fine-tune the model to improve its predictive performance. Thank you.
Great, thank you so much, Singoro. We do have time for questions if there are any. Hannah?
Hi, thank you for a great talk. There seems to be some areas of the map where it's doing a really nice job of capturing what's going on, and then some areas where it's kind of missing a little bit. So there's an area on the left and kind of an area bottom right. Do you have any insight into what aspect of the model is missing some of those areas? So yeah, like the bottom right area, there seems to be quite a lot of like the pale yellow color. And then also on the left, kind of above the lake, there's kind of a hot spot there that's not really coming up. It's kind of coming up, I guess. But yeah, any insight into what's going on in those areas?
So as I've explained, it's ongoing work. So we're trying to explore the different reasons why we're observing what we're observing. So I think it's about 3 months old. So yeah, getting on.
Jaylene, thank you.
Thank you for the talk. I was also super interested to see it. I think I have a little bit of a question of like assessing where we are now in terms of using these kinds of outputs to inform decision making. So like, as you have said, like there's work ongoing trying to figure out what might be, potential problems with the model. So I understand like that's ongoing, but with what you have now, do you think it meets a good enough bar to inform some decisions, or do you think not yet? And how would you know when it clears like a higher bar to be more informative and more helpful for decision making?
So the cutoff of where you think your model is good enough for decision making, I honestly don't know how I would answer that or how I would come up with that. I guess we can go on with the model testing and variation and putting in all the covariates that we think are, and as an iterative process. But I think another thing would be the findings, comparing the findings of our model or our data with previous findings or findings from other studies to see if it actually does represent or it correlates to what other people have found. I'm not sure.
Amelia, thanks.
Thanks for a really great talk. I have a question that's also related closely to the data collection itself, and it's effectively about denominators, right? When I see prevalence here, how am I supposed to interpret that number? So I'm wondering, when you're thinking about the data that was collected and what the denominator is for that population, are we supposed to be interpreting this data as this is prevalence among the children who were in school that day, among all of the children who are enrolled in the school? Or is this supposed to be a prevalence among the entire school age population, whether or not they're actually actively attending school, right? I'm trying to understand what that number is really representing.
So my understanding would be the prevalence across all the school-going children. So whether so that's why I was saying you would have some missing data if they miss school that day. Yeah.
Great. Thank you very much, Sangoro, and all of our question askers today. It was great to see all of these different spatial analyses trying to capture our heterogeneity in both parasite prevalence and our vector species. So final round of applause for our speakers.